Hi and Assalamualaikum. Today our group will be presenting about direct shear test. First is the objective of the test. The objective of the test is to determine the shear strength parameters for a given soil using the direct shear test. Moving on to the introduction, the test is carried out on either undisturbed samples or remolded samples. To facilitate the remolding purpose, a soil sample may be compacted at optimum moisture content in a compaction mold. Then, specimen for the direct shear test could be obtained using the correct cutter provided. Alternatively, sand sample can be placed in a dry state at a required density in the assembled shear box. A normal load is applied to the specimen and the specimen is sheared across the predetermined horizontal plane between two halves of the shear box. Measurements of shear load, shear displacement and normal displacement are recorded. The test is repeated for two or more identical specimens under different normal loads. From the results, the shear strength parameters can be determined.
For apparatus, we use shear box carriage, retaining plate, porous plate, perforated plate, loading pad, and weighing tools. Next, we look at how the test was conducted. First, the soil sample was weighted and all the apparatus were arranged based on the diagram. After that, two halves of the shear box was fixed by means of fixing screw. The loading yoke was placed on the diagram pad and the hanger was lifted carefully on the top of the loading yoke. The correct loading was then applied to the hanger pad after the proving ring was set to 0. Next, the upper half to the lower half that clamped by screw was carefully removed. After that, reading of horizontal and force die gauge at regular interval was recorded. Finally, the test was repeated for other samples under different vertical compressive stress.
So this is the result for specimen number 1, 2 and 3. So we are going to calculate the value of shear stress, strain and normal stress. So the formula of shear stress is force divided by A. In order to find the force, we have to multiply the dial gauge of the proving ring with a constant 0.00875 and then we divide it with the area of 3600 and this is the answer. And then the formula of strain is the change of length divided with the total length. So in order to find the change of length, the dial gauge of the displacement, which is 50, times with the constant 0.002 and then we divide it with the formula is force divided by the area. The force we take is the kilonewton of the load here divided with the area, which is 3600 and this is the answer. And lastly, we will plot a graph of shear stress versus strain for the 3 specimens and we will plot the graph of shear stress versus normal stress.
From the result, the graph of shear stress versus strain and graph of shear stress versus normal stress are plotted to determine the shear strength parameters for the specimens. With the determined value from the graph of shear stress versus strain, graph of shear stress versus normal stress is plotted. The cohesion of the soil and the angle of friction of soil are determined. The cohesion of soil is the intercept of y-axis and the angle of friction is the angle of the linear line produced called line slope. From the graph, the cohesion of soil is 0.0 kN per meter square as the sample of soil used is sand. As we know that sand is a type of coarse-grained soil and is assumed cohesionless. From the graph, the angle of friction is 28 degrees. The direct shear test has advantages and disadvantages. It is simple and fast, especially for sands. The failure that occurs is along a single surface which approximates observed slip of shear type failure in natural soil. The figures show the plotted graph for specimen 1 and specimen 2. The strain is increased when the shear stress increases. For the specimen 3, the shear stress is constant until it reaches a certain point of strain and begin to increase. And for the shear stress versus normal graph, the shear stress is directly proportional to the normal stress.
As a conclusion, we achieved the objective of the experiment, which is to determine the parameter of shear strength of soil, cohesion, and angle of friction. From the experiment that we have done, the value of cohesion C is 0 kN per meter squared, as the soil used for the experiment is coarse-grained soil, which is sand, and the value of friction angle is 28 degrees. The direct shear test can be used to measure the effective stress parameters of any type of soil, as long as the fall pressure induced by the normal force and the shear force can dissipate with time. For the experiment, we use clean sand as a sample. so there is no problem as the pore pressure dissipates readily. However, in the case of highly plastic clays, it is merely necessary to have a suitable strain rate so that the pore pressure can dissipate with time. Direct shear tests can be performed under several conditions. The sample is normally saturated before the test is run. The test can be run at the in situ moisture content. Before we find the value of cohesion and friction angle, we must plot the graph from the data that we get from the experiment. The result of the test on each specimen are plotted on a graph with the peak stress on the x-axis and the confining stress on the y-axis. The y-intercept of the line which fits the test result is the cohesion, and the slope of the line is the friction angle. And that's all from us. Thank you.